5.1, 5.4, part 1. I would take notes because I'm going to let you use this on the quiz tomorrow. Was long division, right? Long division of polynomials. And don't make me use profanity, otherwise I'll have to get rid of the film. All right, suppose I have the polynomial x cubed plus 4x squared minus 38x and minus 42. And I'm going to divide that by x minus 8. Well, we do it just like we did in elementary school when we have, dividing numbers. So I have the polynomial x cubed plus 4x squared minus 38x minus 4 divided by, my divisor is x minus 8. All right, so we're going to start off with the divisor, x minus 8. We need to multiply that first x by something to get x cubed. Well, what am I going to multiply by? That's right, folks, x squared. So my first number is x squared. Finish distributing it to the minus 8. I get minus 8x squared. So that's my product. X cubed minus 8x squared. Now, I'm going to be nice about this because I'm recording. Why wouldn't you be writing this down if you could use it on the quiz tomorrow? No. Just simple question, why? Okay. So you need to refocus, right? Good man. Okay, so I'm going to subtract this product, the entire product. Okay? So I get x cubed minus x cubed. I should get a 0 there. If you don't get a 0 there, it's something wrong. 4x squared. Now I'm minusing a minus. So I got a double negative here. So I'm actually adding 8x squared, which is 12x squared. Okay, bring down your next term, number, digit, however you want to think about it. Minus 38x. And I start the process over again. I'm going to multiply x minus 8 by a number, and that first number has to be 12x squared. So what am I going to multiply by? Well, I need a 12, and I need another x. So I'm going to multiply it by a positive 12x. Finish distributing it. 12x times 8, negative 8, so it's a minus 96x. There's my product. 12x squared minus a 96x. I'm subtracting the entire product. $12x squared minus 12x squared. There's my 0. Again, I've got that double negative here, so I'm adding 96x to 38x. Gives me 58x. Bring down your final term, digit, number, whatever you want to call it. And we have one more time we got to do the process over. What am I going to multiply x minus 8 by to get 58x? Well, I'm going to multiply x by 58. So my last number here is 58. They're finished distributing. 58 times negative 8 is a negative 64. Carry the 6, 46, 464. Subtract my product, 58x minus 464. Subtract the entire quantity. 0. Negative 4 minus a minus, so I'm adding again, is negative. Did I write that down correctly? Ooh, my other classes I used 42. Let's use 42 to be consistent. Okay, negative 42 plus 464 gives me a positive 422. So my answer, let's see, I got an x squared plus 12x plus 58. And then I have a remainder of plus 422 over my divisor x. Questions? Okay, part 2 was synthetic division. Okay, synthetic division. Let's see, we didn't have the variables, right? So suppose I had a problem. X cubed plus 6x squared minus 34. And I give you one of the zeros. X equals negative 3. Well, synthetically divide that. To see my zero I gave you, negative 3. My coefficients, I have 1x cubed, a 6x squared. And what's my coefficient for x to the? Well, I don't have one in there, do I? So I must be adding a 0 x to the first. So my coefficient for 0, x to the first, is 0. Then I got a negative 34. Okay, now instead of subtracting, we add these. Now instead of putting my add sign over here, I'm going to put it right under the 1, and I'm going to tell you why in just a second. Bring down that 1, multiply 1 times negative 3, I get negative 3. 6 plus negative 3 is positive 3. Now, the reason why I put that plus sign underneath the 1, because a lot of you guys made the mistake of putting this 3 under the 1. It goes under the second number. So keep going. 3 times negative 3, negative 9, 0 plus negative 9, negative 9. Negative 9 times negative 3, positive 27. Negative 34 plus 27 minus 7. So my answer is, well, I divided out one of the x's, so I'm at a 1x squared now. plus a 3x minus a 9. And this time my remainder is a minus 7. Now be careful, the divisor isn't negative 3. It's going to be x plus 3. Okay? So there's two parts of the quiz from the last quiz that we're going to have tomorrow. You can use this on the quiz. If you want it, take a picture of it. Do whatever. All right. Here's the rest of it. We're going to do advanced factoring. And again, you can use your purple flowcharts and your yellow sheets. First, what I'm going to do is a sum of squares. Okay. Now, 27 happens to be a perfect cube. Not squares, cubes. It happens to be 3 cubed. Well, I already have my x cubed. And 8 happens to be 2 cubed. And that's what that yellow sheet can tell you. Okay, it's got perfect cubes on there. Now you're going to have to use A and B. I like writing them out. I see a lot of people are skipping these steps, and it's really kind of important. You're making mistakes. My A is going to be the base of what's being cubed. My base, 3x, is what's being cubed. My B is the base 2 being cubed. Well, if you look at the formula on your sheet, you're going to have the factors, the terms, 3x plus 2, A plus B, so it's 3x plus 2. And then I have A squared. What's A squared? You take an A and you're squaring it, square each number. So I have 9x squared. The formula says I have a minus sign here, and it's going to be A times B. Well, 3x times 2, 6x, plus 2 squared, B squared, 4. That's my answer. Okay, I'm going to do 2 more, maybe 3 more. 2A. On your purple flow charts, it says, well, the first thing I'm going to do is take out any common term. Can I take out any common terms, any common factors of this? Well, I can take out a 7, and I can take out 1x. 7x to the 5th divided by 7x. Well, I have x to the 4th left over. Minus 112 divided by 7 is, 16. And I'm taking out the x. This is a difference of squares. Okay. I have x squared being squared, and I have 4 being squared. So I follow the formula for that. Don't forget your 7x. What's my A and my B? Well, my A is going to be, I'm squaring x squared. My B is, I'm squaring 4. So I have A plus B, x squared plus 4, and I have x squared minus 4. Now, don't stop, because I got a difference of squares here. Okay. My A, well, this time my x is being squared, and my B, what's the square root of 4? 2. 2 is being squared. So don't forget your 7x, x squared plus 4. And now I've got my a plus b and a minus b. A is x plus b, a minus b. There's my answer. Okay. Let's do 3a. I have 4 terms here. Again, following your flow chart, 4 terms, grouping. So group 2 terms. This first quantity I can take out. Let's see, I can take out a 4. And this one has 3 x's, this one 2 x's, so I can take out 2 x's. 4x cubed divided by 4x squared is x to the first. 8x squared divided by 4x squared, 2. The second grouping, I have a negative sign first, so I'm going to take out a negative, and I can take out a negative 5. Negative 5x squared divided by negative 5 is a positive x. Negative 10 divided by negative 5 is a positive 2. The whole idea here is to get the same quantity. Okay, that becomes one of my factors, x plus 2. My other factor, well, that's what I have left over, the 4x squared and the minus 5. Take a couple of seconds, look at this. 5 is not a perfect square, so it's not going to factor. Sometimes it does, just like up here. Be careful. All right, 5.6, fundamental theorem of algebra. This is where things did not go too well. Okay. First of all, using your calculator. So what's the first thing you're going to do? Put it in your calculator, right? Find all the rational zeros. Okay. So let's put this in our calculator and find all the rational zeros. Rational meaning a number, not an imaginary number. Okay, so I have x cubed. X cubed. So put this in your calculator. Use calculator. Okay. X cubed minus x squared plus 25 minus 25. Graph. All right. Not sure where the zeros are. I'm going to try, before I use second trace and all that other stuff, I'm going to try looking at my chart. Okay, so I'm going to go to second graph. And again, I know that my zeros, the y value is 0. And actually, I do have a couple of zeros here. Okay, I have 0, 0, and I have 1, 0. So zeros from the calculator. I have a 0 and a 1. Let me make sure I type this. X cubed minus x squared. Oh, I forgot an x. See, I knew something wasn't right. Much better. Is this what you guys got? All right. So again, it looks like I have a 0 at 0. I'm going to check my chart. And I'm going to look at 0. And oops, I don't have 0 there. Okay. So this time I'm going to have to use the second trace button to calculate my 0. Okay, I'm going to go back to my graph. Second trace, I need to find my 0. Enter. I'm to the left of my 0. I can hit enter. I got to get above the x-axis for the other right bound. Hit 0, and then hit 0 again. And I get 0.08, comma 0. So I'm just going to use 0.1. 0.1. And for our purposes, we're going to use 0. This still, something's wrong. See, x squared plus 25. See, I forgot a 25. Okay, third time's the charm. Second graph. And I do have a 0 this time. It's just positive, plus 1. My mistake. I made 2 mistakes in a row. But you see what I did? Okay, I looked at it, I'm like, hey, something's wrong. We never divided by a decimal before. So I went back and looked. You guys gotta, cut your mistakes every once in a while. It happens very easily. Okay, so I'm gonna divide by 1. My coefficients here, 1x cubed, negative 1x squared, positive 25x, and a negative 25. Okay, I'm going to add these, bring down the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. Times 1, 0, plus 25. 25 times 1 is 25, plus negative 25, 0. So I have, let's see, I took out one of the x's, so this is 1x cubed, squared, plus 0x plus 25, or simplified, x squared plus 25. Now, unfortunately, this is not a difference of squares. It's a sum of squares. I still have to find the roots because I know that I have to find 3 zeros because it's cubic. Well, what am I going to use? You ask. How much more fun can we have? Well, we can use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Bet you didn't think you were going to use this formula all that much. Okay, what's my a? Coefficient of x squared, 1. What's my b? Coefficient of x to the first, 0. My c? My constant, 25. Okay, so x equals negative 0 plus or minus my b squared, which is 0 squared, minus 4 times a, which is 1, times c, which is 25, all over 2 times a, which is 1. And I'm going to go off to the side here, do my discriminant with the radical. And I get, well, I'm not even going to use a 0 because 0 is just 0, 0 squared. So I get the square root of negative 4 times 1 is negative 4, times 25 is negative 100. Well, I got a negative sign, so that's going to be a square root of negative 1. And then I've got the square root of 100. Square root of 100, 10. Square root of -1 is I. So I'm going to replace the whole discriminant down. So I get -0. I'm not even going to put that on there. Plus or minus. I'm replacing this whole thing with 10I divided by 2 times 1 is 2. Now, I'd be happy if you put that as an answer. I'm okay with that. So I have the 0, 1. I have plus or minus 10I over 2. But I would prefer that you guys simplify this. 2 goes into 10 5 times. So I'll take either one. I would prefer simplify. Okay? And the last thing we're going to have in the quiz tomorrow, analyzing graphs of polynomials. Okay, so we've been doing this, what, the past 2 or 3 days, right? Okay, graph the polynomial and find all the listed features, this thing. So again, the first thing I'm going to do here to find the x-intercepts, I'm going to put it in my calculator. So I got 2x cubed minus 8x squared plus, let's see if I not make mistakes this time, 2x plus 5, looks good, graph it. Okay, my zeros. Unfortunately here, my zeros are going to be decimals or fractions. So for each one of these, I'm going to have to use the second trace button. Second trace to calculate our zeros. Well, the first one, get to the left of it, enter, go above the x-axis for the right bound, hit enter, enter again, and I get -0.6. And my y's are always going to be 0, right? My second one, trace, 0. Second one, this time my left bound's above the x-axis, my right bound's below the x-axis, hit enter again, and I get 1.0. Need my third one, trace, 0. Left bound's going to be below the x-axis, hit enter, right bound above, enter, enter, and I get 3.5. Okay, next, our max and mins. So I'm going to do the max, second trace, max, enter. I know I'm going a little fast, but luckily I'll be able to put this on the Google Classroom. Left bound, enter, right bound, enter, enter, and the point is 0.1, comma, 5.1. My min, second trace to calculate the min, left bound, enter, right bound, enter, enter again, and I get 2.5, comma, -8.8. Okay, I'm going to put all these points on the graph. So I got -0.6, which is about a -half, 1.1, just a little over 1, and 3.5. 0.1, 5.1. Was that a -0.1? No. 0.1, 5. Right about there. And then my minimum, 2.5, -8, almost 9. Going to sketch my graph. Coming from negative infinity, goes through my first 0, hits my max, turning point, goes through the second 0, hits the min, turning point, third 0, and up. Okay, increasing. This is where I'd like to make a number line for the x-axis, and I have my negative infinity, positive infinity, and I like putting my max and min numbers on there, the x values. That's all we need. Okay, so the smaller one is my 0.1, and then my bigger one is going to be 2.5. Okay, you ready? So from negative infinity, it's going to be increasing to the first x value of my max. So from negative infinity to the 0.1 is increasing. Then it continues right where it left off, decreasing from x value of the max to x value of the min. Then it increases back from the x value of the min to positive infinity. This is a lot easier to get my interval notations right. So it's increasing from negative infinity to 0.1, decreasing from 0.1 to 2.5. 0.1, 2.5. Then it's going to increase again, 2.5 to positive infinity. Since I got two intervals here, I should put a union. And the last thing we have here is the end behavior. So as x goes to the left or negative infinity, as start at the origin, as x goes to negative infinity, my y goes to negative infinity. As my x goes to positive infinity, start at the origin, as x goes to positive infinity or to the right, my y goes to positive. So there's a lot going on with fundamental theorem of algebra and analyzing the graphs. I am here in the math lab today, so if you need extra help, really don't understand something, stop by. It's in East 145. Got it? I know we went quick. What's that? I didn't hear you, but if you need help, I don't know if that's what you were saying.